So I'm Moses. The subtitle of this talk is So You Want to Add a 9? Here, when we're talking about nines, we're talking about nines of reliability, where we say, like, generally we want your service to be alive most of the time. We're talking about what percentage of the time are you alive? The question ends up being, are you 1 9, which would be 90% of the time, which is sort of pretty bad? Are you 2 9s, 99% of the time? Still actually pretty bad. 3 9s, now we're getting somewhere. Okay, I'm Moses Nakamura. I work at Twitter. I work on Finagle, which is an extensible RPC framework. Follow me, please. I need more engagement. I actually get paid proportional to the number of followers I have, so that's not true. But okay, so sort of the core idea of this talk is that as you scale your organization up, it becomes actually much harder to maintain your reliability. This is true both as you scale your organization up and as you scale your architecture up. So we need to change the way that we look at reliability as we grow our company in order to keep up with those problems in scaling your reliability. So who cares? So Twitter cares a lot. Probably some of you will recognize this image. This is the fail whale. This used to be what Twitter was known for. Basically, our reputation was if you need somewhere to go look at a 404 page, we have a great 404 page. That wasn't really what we wanted to be known for. Our current brand strategy is pretty different, actually. So that was like 8 years ago, and since then we've made a lot of pretty significant improvements. A lot of these improvements have been on these metrics, things like uptime. When we're talking about nines of reliability, this is often what we're talking about in terms of like minutes per quarter. Dollars, like when your website goes down, often you're losing dollars, whether it's ad dollars or if someone was going to pay you directly for some service or whatever. Your success rate, which is the number of successful responses you have divided by the number of queries you have. The mean time between failures and the mean time to resolution. These are all things which are going to directly impact your users and things we care a lot about. I work on Finagle. Finagle has a pretty big focus on robustness and resiliency in the face of this class of failures, like failures in a distributed system. Twitter is pretty much all, like the online parts, the parts that you interact with, are pretty much all microservice architecture right now. So something we're thinking a lot about as we were building Finagle and as we scaled up Twitter was how can we continue to be reliable as we increase in scale? So a lot of the techniques that I'm going to talk about are built into Finagle. So really what I want people to get out of this talk is not necessarily what Finagle does, although that is sort of what this talk is going to be about, but more when we ran into a problem, here's how we looked at that problem, here's how we solved it, and here's why we think that this was a good, complete solution to that problem. So when you're first starting out your company, sort of the first thing that you do as like you have your first big major failures, you think, okay, we need to start owning our own failures, and we need to really like have people take responsibility for it. And the first core idea is teams should own their own failures. This makes a lot of sense. As a company, we want teams to be aligned correctly. And one of them is if the site goes down, you get woken up in the middle of the night. Sort of the kinds of failures that people end up owning are going to be like background noise failures. These are the things that just like fill up your logs and you just start ignoring. Gray failures, Heisenbugs, temporarily overloaded hosts, crashes. Then the other kinds of things are bugs. If you just introduce a bug which just takes down the website, your team is going to have to own that. One interesting thing is that pretty much everybody writes bugs. I mean, I don't write bugs anymore, but most people still write bugs. So as you hire more people, that's also going to introduce the rate at which you increase bugs to your organization. One technique that people have to stop writing so many bugs is they introduce process to reduce the number of bugs. Things to increase your code quality, like code reviews or unit tests. integration tests, all these kinds of things. So when we start running into failures, one of the ones we'll often run into is a probabilistic failure. Now suppose that this remote host has a 90% success rate. That's, I would say, not so good. One simple and easy solution is the caller says, how about we just keep on trying after we fail once, instead of saying, I failed, I guess that's just that's it. How about we add retries? Suddenly from something that has 90% success rate, if you add 2 extra tries, you can get it up to 3 nines of success. What if there's a bug in the release? Suddenly you deploy and your success rate drops down to 0. On the other hand, if instead you make it a canary and you say, oh, look, the success rate on that one host dropped to 0, you can avoid the massive catastrophic failure you would have hit otherwise. So those are sort of like early attempts that people usually end up making. As you scale up a little bit more, you end up thinking, like maybe if we had a team, we could start solving these in a more generic way. For example, with Finagle, we added a retry filter. Suddenly, instead of everyone having to build their own retries and retry policies and exponential backoffs and jitter and all that stuff into their own services, we could have a single place where we could put all of it. So if each app has a 10% chance of failure, and we start having this big microservice architecture, then as we scale up, things can get more and more tricky. So okay, that number is wrong. But that number is supposed to be 65%, where basically the idea is if each tier has a 10% chance of failure, then your overall success rate is going to be 65%, which is pretty bad, I would say. It would mean that if someone goes and wants to go 3 times on your website, one of those times is going to be a failure, and you have to reload the page. If instead we added retries to each of these edges, suddenly it'll go to 99.6%, which is still not amazing, but much better. All right, less common failure modes. So you can run into all kinds of operational failure. For example, even just when we do a rolling restart, often you'll find that there are lots of edges where you can start failing. One example is when a server is no longer serving traffic, but your client doesn't realize it yet and keeps on sending your server traffic. Or, for example, when your server is starting up, but it's not yet warm enough in order to serve a response successfully. Bad remote hosts, like if a remote host suddenly has bad hardware or has gotten into a bad state and your client hasn't noticed yet. Or if your mean time to recovery is slow, like your operators don't have enough tools in order to make the right decisions. So when we have a caller talking to a receiver, sometimes what we think is, what's happening? Now, this is a chart that might suggest what happens when that caller talks to that receiver. So actually, there are 3 services here. There's service A, service B, and service C. Service A sends a request to service B. Service B sends a request to service C. Service C is not able to serve it correctly and sends a failed response back. And service B sends a subsequent request to service C, which is a retry. C is able to serve that one correctly and then comes back to A. But lots of things happened here. So what kinds of information might we want to know here? Here are just some examples. You might want to know, like, what was the duration of this request? What was the duration of each of the requests from B to C? It's pretty valuable to know what failure happened, what time that failure was, and also it's valuable to know that you did a retry. These are the kinds of things we end up putting in tracing and logging and metrics. So some of the useful things that you want to know about your server are going to be tracing, logging, metrics, also config information, and which remote host you're talking to. So failures while rolling. I talked about this a little bit before. Basically, imagine that instead of just one remote host, this receiver is actually, say, like 10% of your nodes. Suddenly, like, you're not able to talk to that host because it's being rolled right now. So start sending requests. and some of them are successful, but then the rest of them, it's like, oh wait, that server is now dead, I just didn't notice. So you're going to get this sort of unhappy like connection closed error or something like that. Instead, if we build more sophisticated information into our protocols, like go-aways, for example, in HTTP2, or tdrains and mucks, then your client can know much better, oh, well, I now know that I'm not going to get any responses for my other requests. So these final requests, which I asked for, I'm just going to assume I'm never going to get a response, and I'm going to send them to another remote host. So basically, a caller goes to the receiver says, hey, chill out. And then the caller chills out and goes somewhere else. Another example of something that can happen is when you have one bad egg. For example, the case where one of the remote hosts has bad hardware or ends up being slow because it's in a bad state, doing a lot of GCs, something like that. Instead of just sending a bunch of bad responses back, when you send a bunch of responses back, the caller can say, oh, that one is like failing 75% of the time. Maybe I shouldn't send that one so much traffic. Maybe I should send it 0 traffic until it recovers. So as we continue scaling up our organization, we begin to run into problems which become rare and which basically individual teams can't be expected to solve. Things where it's like you have a 1% chance of running into it. Does it really make sense to ask every single team to build a custom solution to worry about this one problem? No, but when we're talking about 100 teams, if that means that one team is definitely going to run into it and it's going to definitely take down the website, maybe it is useful to build it, but in a generic way. So going back to what we were saying about people introducing bugs, if each person introduces a bug every month, you double the size of your engineering team, you're going to double the rate at which you're introducing bugs. So some examples of failures, which you begin to only see at much larger scales, end up being retry storms, environmental pressures, overloads caused by the grand caller, where it's not your caller who's causing the problem, isn't who's overloading you, but it's the caller's caller. So for retry storms, you can see the caller is sending requests to the receiver, and the receiver is sending back a bunch of bad responses. And so the caller responds by saying, okay, the whippings will increase until service improves. And so this just overloads the remote host even harder. Instead, if we have retry budgets, where you say, okay, I'm only going to allow some small percentage of requests to be retries. I say, okay, only up to 20% of requests are allowed to be retries. Then suddenly things can get much better. So overload. This is when maybe you've already figured out your retry storm scenario, but the remote host is just overloaded. You didn't expect to get so much traffic, and so the server is having trouble. One problem we can run into is sort of a queuing theory problem, where you're shoving requests into your queue, which is your server now, and your server is not able to give you back responses as fast as you're shoving requests in. If the server realizes that it's overloaded and starts sending Nacks back, then that can be a really good signal to the client that should slow down. We have other signals, like for example, the server just slowing down, but those can often be slower, or it can be a little bit trickier for the server to respond to those reactively. So the caller sends a bunch of traffic to the receiver sends back Nacks. Now is not really the best time. The client stops sending as many. Another example that can happen is if any of you, we use Mesos and Aurora, which allows us to co-locate applications on the same host. Sometimes because Mesos and Aurora don't give us perfect isolation, we can run into problems with noisy neighbors. Like if you've ever been scheduled on the same host as like somebody who's doing a ton of disk I/O, you might have seen this kind of thing, where the server ends up slowing down, and it's very difficult to tell until you go and sort of look at the stats on the overall machine. You see like, oh wow, CPU is being really utilized a lot, much more than I expected it to be. One thing is that if we build in tools into our servers to detect this kind of thing, then they can respond much better. So the receiver thinks, okay, I'm being throttled for various CPU reasons, and I need to tell my client that I'm being throttled so that they'll stop sending me so much traffic. We can use Nack for this also. So basically, the remote host says, I'm being throttled, and I need you to chill out and talk to somebody else in the meantime. So you send a bunch of Nacks. Client says, OK, I don't want to talk to that thing that's sending Nacks. I don't really care why. And then stops talking to you and talks to someone who's not being throttled. Then after your rude neighbor has gone away, then you can start sending successful responses. Or as some people do, you can just kill yourself. OK. So one lesson learned here is that it can be useful to have not just one team, like the Finagle team. It can be useful to have many other teams that are serving other kinds of similar parallel reasons, all focused on resiliency and looking at it from a global point of view. It can be very useful to have observability storage, because if you're just exporting stats, it's not going to be useful when you want to say, OK, something really bad happened 5 minutes ago. What was it? If all you have is the now information, you're not going to be able to figure it out. Automations that you know, like, OK, like this is something I would have restarted by hand. Like maybe I don't want to be woken up, and I already know what things look like when they need to be restarted by hand. Just don't do it by hand anymore. Deploys. How can we make our deploys standardized and like not surprising anymore? How can we coordinate during a site-wide outage, which might affect multiple different services? We should have a single team which can help us with that. How can we spread reliability best practices when the generic solution might not work for every single problem? Another big thing is that you should make your failures loudly. Failures are really valuable information, and if you're not sharing this gift with everyone else, then you're depriving the organization of institutional knowledge. We need to be able to have a global view so that people aren't stepping on each other's toes. We also need to coordinate for the same reason. We need to empower teams in order to give them the actual ability to solve these problems completely. And we want to be able to keep a history of these things. This is one of the big reasons why you should make your failures loudly, so that when you personally leave your company, you're not taking that institutional knowledge with you. Also, by making them loudly, you set a good example for other people and allow people to not be so concerned about being blamed for making failures and trying to paper them over instead of being clear about what the problem was so that you can solve it completely. All right, any questions? What's up?
So about the history of failures, do you have any good solution or something like that?
OK, so the question is, how do you solve the problem of institutional knowledge? It's really hard. I would say there are good sort of process improvements. One example is having like a recurring sort of war stories event where you can sort of spread stories about awful things that happen so people can remember these kinds of things. It can also be really useful just to keep mailing lists around and to have most information in like this nice searchable way. Lots of people use Slack for this now, I hear. As long as you have a Slack which can search for a really long time back, that should also be fine. Yeah, it's a hard problem. Wikis are OK. The question is, how many nines do we target? It depends a lot on a service-to-service basis. Like some things, it matters a lot when it's not healthy, like ads things or the timeline. Some things, it doesn't matter that much. So I would say on the like somewhere between 2 and 4, typically. OK, I guess that's it.